We got a lot of now working with the workflow languages, and in this case, we be looking at SnakeMake. I don't know. Some of us have had experience with it. Maybe there may be one or two people who are actually, users for SnakeMake, and we will sort of go through slides prepared by Phil, and he passes his regards. I just talked to him not so long ago. And as Kirsty mentioned, if you got any questions, and I've discussed that with Phil, I don't know whether we can, I don't know whether we got Slack installed on our laptops, on our working spaces. Maybe something to raise with IT if that is possible, because ideally we have a Slack channel, but you can install Slack on your phone as well. And Kirsty set up a Slack channel, and within this channel, sort of the NGS Academy, you also have access to other conversations for other courses that Tony and Kirsty have been coordinating, organizing, and running. And we are here. I just post this one here. And what Phil has also mentioned is that if you run into something or you got a question, feel free, and he will also be able to answer. He's prepared the slides, and maybe once we go through it and we run into issues or questions. Oh, I see Kibet is on the channel. So we can all have this discussion, and we can answer and have some sort of a conversation. And that can continue way past this course as a way to talk together. So I'll have Benson and where's Jane as my assistants today, because and John there, who's worked with workflows. And tomorrow, John is going to delve a little bit actually into sort of our next flow as well. So without any further ado, I'll dive into the lectures. And again, I don't know. Yeah, my aim was to make this a little bit interactive, and I don't know how do we write our jobs? How do we run everything in the command line? I do that often sometimes. Or do you prepare a bash script and task it? So you can say this one is for running BWA, maybe this for running analysis Y, or you just run it in your sort of a home directory, right? So it turns out that doing those sort of things, a lot of people have thought about it, and there are multiple ways. I think there are quite a number of this sort of workflow agents, and whatever you think about it, in most computational works, like you said, it's sort of transactions, and you can think about from a start to an end, and you got intermediate steps, and you got data coming in, and it's getting massaged, changed, and often you get the input of one step or rather the output for a given step is the input to another step or another process. So it turns out you can abstract these concepts, and you can prepare what they call, like workflow agents that can describe and help you formalize it. And it turns out also that you can also have workflow specifications, and workflow languages that you can just write the spec, and you expect that any workflow agent can read that spec and interpret it and generate code that then goes on to fulfill the task. So that's really high level, and sometimes really useful. So today we're going to go through SnakeMake, which is one such abstraction, and just going to tab through I think why are we going to talk to you about workflows and managers? I think I've kind of gone through it, and the advantages of these workflow managers is that each job and task can run within its own environment, and as we've seen, its own container. So you can have multiple tasks. You can whatever you abstract as a job, the things we were talking about yesterday, and they can run in their own environments, and failures can get handled elegantly, and also they can be restarted. I don't know whether you got into a situation where you're running some piece of work on your computer, and it slowed all the resources, and you have to reboot. You have to restart your computer all over again, and you may have other processes that are running, and it's not always the most elegant way to handle failure. So you'd like a process where you can have that thing in an isolated environment, and you don't have to completely shut down a computer or an entire HPC system to mitigate or to sort out a failure. It also turns out these things are portable, and you can send it to a collaborator, and ideally it should work. So if I wanted to do a QC for SARS-CoV-2 data, and I know the tools that I want to do and the steps that are involved, I can script it, and if I want to set that up to Kibet and wants to do something very similar, that can be ported, because all I need to do is send him the workflow, and within it, you have all the steps that are needed to carry out the different tasks. And again, this is scalable. And the idea is, whatever you can do on your laptop, you can take it on and do it on an even bigger machine. It doesn't matter what environment it is. It might not matter whether you're on Linux or Windows. If you've got this Docker and so on installed on Mac, your workflow will run quite okay across those operating systems. And also, if you're running this on your laptop and for some reason you got tons of data and you got access to a supercomputer, you should be able to take those data, the same workflow, and and run it ideally in the same way across large HPC environments with minimal changes. Yeah. So the minimal changes there could be just to specify how input and output goes in, and and so on. And they're efficient in the idea that you can run multiple jobs all in parallel, right? So often most tools that you will run will have a -j argument or jobs, which allow you to take advantage of modern computers that have multiple cores or processors, and if a task involves a lot of repetition, you can do it multiple times. You can take advantage of modern computers. So way back, you'd have one computer, one processor per computer, but the technology has just gone, real crazy, and you got multiple cores, really high-end CPUs, and you can abstract that, and often you can take advantage of those cores and run multiple jobs in parallel. Okay, so and this turns out almost always when you got large data, it's not always the computation that that is the bottleneck. It's how do you channel that across the computer, because it's a large data set, and you're doing an atomic job, but then you're doing it in a sequential way. So one is waiting for the other to finish, so that then what if you could just abstract that and run all of them in parallel? Okay, so you can save on time. So it turns out that most of these workflows, when you arrange your job, it becomes easier. Again, most of the efficiency from parallelization is quite a hot topic, and it's handled by different languages, and sometimes they can come around to bite you, running into race conditions and so on. So it's really nice when you got a workflow engine that abstracts that and make it easy for you, or at least mitigates against failure. Okay, so it turns out to be really useful. So there are several of these guys. We're gonna look at SnakeMake because it's quite easy in terms of understanding and the concepts, and we got others that I really like. For example, Nextflow, there's Cramo, there's Galaxy, which is very visual, really nice, and maybe I don't know if you attended Peter's is an expert on Galaxy. Really nice way, and you organize your modules and you just drag and drop things. Of course, there may be issues with that in terms of challenges, because you having a visual system, but the team behind Galaxy is fantastic, and the progress that's been made I think is great in terms of that. I think Galaxy now can even emit specs in common workflow language, for example, that then you can take and run on a different agent. And you got LUFOS and B pipe that have been used, and maybe you can Google them and see how they're used. So again, what Phil's saying here is that choosing one of them is a trade-off between learning curve, feature richness, and ease of use. Okay. And then just going back to what Tony was talking about just earlier on about how do you choose those trade-offs? Yeah. So maybe I got a very short time, and I need to give results within the next 2 weeks or the next 1 week, and I'm going to choose something that will allow me maybe something like SnakeMake, where I can get productive very quickly, but then I may not have all the bells and whistles. Okay. And then I may choose something like Nextflow, and the DSLs and the concepts are slightly different, not so far off from SnakeMake, but it's a different way of thinking about it. Or you may choose something like Chromo or BPipe, or just old school Make, where SnakeMake, the Make here and SnakeMake, the Make, which is an old tool used for compiling scripts. If you've ever written C script or done C programming, often you get different aspects, different tasks in different files, and you need to make a program, right? So it turns out that you compile different things all together, and the way you do that is using a spec or the Make language, and you can take advantage of Make. Some bioinformaticians are really good at, I think they use them to be BioMake, if I remember correctly. And SnakeMake got, I think, a lot of inspiration from Make, and it's all written in Python. Okay. So, so one way to think about SnakeMake scripts is just asking yourself, what is the final thing that I want out of this pipeline? What do I really want out of this pipeline? Okay, and what is the process that will give me that thing? Okay, is thinking about the task. What is it that I want? The project, and what kind of inputs am I going to get, and where do those inputs come from? Okay, are they FASTA files? Are they FASTQ files? Where do they come from? How large are they, maybe? And how will I go about getting the results? So, for example, I may just think about quality control, okay? And I may write a script just for quality control. So I got to think about, okay, so what is my input in that case? It will be raw reads, maybe. And I need something that does the quality control, right? Maybe FastQC or something different. But yeah, I've thought about my input, and then what do I want to get out? Another FASTA file that is now sort of a clean version or QC'd version. Okay, and that's really important to think about what you want to get out of your workflow. Okay. And where do the inputs come from is sort of a feedback. What is the process that will give me what I want? Okay. Yeah. So, sorry. Yeah. Yeah. So this again is just thinking what I've just said is the input files. What kind of files am I going to use? And are they files that are coming from another process upstream or downstream? And is the input output same file format, and so on and so forth. So you got to think a little bit more about it. And yeah, so this one way to think about scripting. Yeah, so I got my raw reads. I'm gonna do a QC through trimming. I'm gonna trim the reads. And I'm going to do an assembly, okay? And therefore, my input is the raw reads. My output for this is the trimmed reads. And the process is read trimming, which sits somewhere in between here. I'm sure if you're bioinformaticians, you've always drawn these sort of diagrams, whether that was to illustrate a point or to describe your workflow, you'd have those sort of boxes, right? So these are the files, that you will be used as your input, and you can think of another process, where now the input is the trim reads, okay, that you received from here, and the output is an assembly.FASTA file. The process is now assembly, okay, so that's the process that we want to run. And again, here, the process here is to gather your assemblies. You got multiple samples, multiple reads. I may want to write all of them into a single FASTA file. And so my input here will be the assembly.FASTA. Okay? Yeah. So I think here is sort of thinking about all these things, or pulling in together from, making that pipeline with each process sort of assisting and helping out to, get the output. Okay, so all working in concert. Okay. So enter SnakeMake, which is based on Python and Make. So I gave a little bit of an introduction to Make. And what it does is you split your workflow into separate rules. Okay, so we're going to separate our work and to think about rules. And one rule per process. Okay, so as I said, we got to think about processes here. So row reads, next step is trim reads. My process is read trimming. Okay, so that's the process that I want to think about. Okay, and therefore I'll split my workflow, all those steps, into those individual processes, and you got some rules, which is, each rule will have a name. It'll have an input file, output, and a command to run to turn the input to output. Okay, so that could be either the fastqc command, or it could be nextclade if you're working with the SARS-CoV data, or whatever it is that is helping you out, or just a simple bash command or awk or whatnot. Okay, that's what you want. Yeah. So, and this is how you'd prepare such. Okay, so this is how you'd write it when you write in your script. Okay, so you get a rule. So here is a rule BWA map. Okay, so this is a mapping, and the input is a file. It's reading from the data genome, and again you got samples A, fastq, C, or fastq. The output is a BAM file that we're going to put in mapped reads, right? And the command that I want to run is this command here. So I'll specify using the shell keyword that this is the script, and we quote it. So what we want to run is BWA mem input. So this is in these braces because essentially we're using Python here, which will pull from or rather maps that input from your spec here. You're going to pipe this, the output of this command, to some tools view with a -sb, and then you get your BAM file. Okay, which will be written here. Okay, so traditionally what you do is that you'd write your BWA mem, it's just a bash script, and you give it a full path and maybe, pipe that. So one way we could do that is, again, we could have just a rule that does just this bit, because this is, again, a process. So this is sort of a process within a process, really, because you got this step here, which now converts your output, or caches your output there, and then takes into another tool, some tools. But because we're using shell command, we can just do that all in one single line. Okay, and that would comprise our mapping rule. Okay, so yes, please.
So from the previous slide, the first line, those are two Or you can have multiple ones?
There are multiple ones in this case, yes. So in here you got, I think, genome.fa as an input and separated with a comma, and then again data, and you have a FASTQ file as well. That will all comprise the input, and you have your output. Okay. Arnold?
So, when you're writing the rules,
Yes.
can you write the first month or
What's that?
short month, WA underscore month?
Mm. Yeah, good one. So SnakeMake is all very Python, and indentation is important. But here I think we are using underscores to separate, and they could be anything. You know, you could have just written BAWA map as one word. It doesn't matter. The key thing is that you rule here is a keyword. So, and the colons are important, and you ident. You know, if you've written Python before, you know, this line here needs to be indented and they need to be consistent. Yeah, whatever you do. I don't know how you use the indentations, but I always replace all my tabs with spaces, 4 spaces. Yeah, just so that when I press the tab key on my computer, rather than actually do tab, it does 4 spaces. It just makes life easier. Okay. And since you're dealing with the text input and output in this case, you know, I think that works. Okay. So the colons are important. These are keywords, and if you use an editor, you know, like VS Code or Vim or whatnot, you know, you can allow them to do like highlighting, you know, and all that. You can get all that markup, like in this case. Okay, depending on which text editor you're using. Okay. So the good thing with this sort of script, maybe I'll come down to that, is that wherever I want to run this, I can always only change my output. The command is there, it's written, output will always be like that. You know, I just change these bits. These are the moving bits. Okay, so it just becomes so easy. And sometimes this might be a complicated command that, you know, I don't always want to keep or remember, right? Or some clever thingy, yeah? So I'm able to do it. So if you saved that file, if you wrote that and you saved it as my mapping pipeline.smk, so the suffix smk for, I think, for SnakeMake, then you can run it as a SnakeMake -s for script my mapping pipeline.smk, assuming that you are in the same directory, or at least you have relative paths to these folders. Okay, and it will execute. Okay. So the other thing is that you can save the contents of the file into just a file called snakefile, and then just run SnakeMake in the directory containing the snake file, and it will just execute that script. Okay, so that's the alternative. So if you decide to name it, you know, explicitly what the script is doing, something that I always prefer, or, you know, if it's one directory and we're thinking about, you know, you got the master script, you can simply run SnakeMake. You just store your file as snake file, capital S snake file, and SnakeMake will identify that script and it will execute it. Okay. So here we got a little bit of a generalization. Rule BWA map, right? What's the difference? Yeah. So one of the things we are doing here, which is I think is really neat with this sort of way of working, is that we can put some generalization. So for example, here is the same thing. We got our input data, genome data, samples, right? So you have a folder called data. Within that folder, you have, you know, samples / sample.fastq, but now we have I generalized a little bit on the sample, okay? And therefore, my output, I want it to contain the same name, and therefore, I'll just say map3/sample.bam, right? And I execute my script, bwamem input, piped into some tools view -b, catch the output and write it to my output. Okay? It's getting more powerful, isn't it? Yeah. So here we are using so the so-called wildcards. By now you would expect all of you to sort of know wildcards. And in this case, the sample to sort of cache the names. Yeah. And what will happen in this case, NCMEC would find all the files matching the pattern, for example, that type of pattern, and run the script bwamem. Okay? So if you got a sample and it matches this pattern, yeah, samples, whatever it is here, .fastq. You know, this could be the name of your sample. It doesn't matter. Okay? And it's going to run that, and it always replaces. So you always end up with a sample name.bam. Okay? So you can execute your job very nicely, very neatly, and you don't have to worry about the names because we can generalize using wildcards. Okay? That was we just said. The sample will propagate through the output so that the output BAM name will match the name of the input FASTQ. Okay? Maybe we'll see that in some examples. So here's another level of generalization, right? So in this case now, we've written, we got our samples,